Now let's look at the application of the low pass, band pass, and high pass filter in terms of example. Let's look at this circuit. If for previous low pass filter we have minus the transfer function, which is minus R2 R1 R2 C2 S plus 1, and we said its body plot looks like this. This here is omega C, which is B 1 over tau 2C2. Okay, let's say if I happen to have this transfer function and its body plot in terms of value to be, let's say, 10. Here it is let's say 10 100 radian per second. So in that case, typical question to us is, if I have input Vi to sine 1t plus sine 10t what will be the VO T steady state? So there are two ways to look at these problems. First of all, sinusoidal in, sinusoidal out. You can always find the output will be input amplitude, sinusoidal in, sinusoidal out will be as a transfer function. The output will be input times magnitude of sinusoidal transfer function times another sine omega t with a phase shift. But if we look at from the filter point of view, we can tell here's meaning corner frequency will be 100, 10 will be here, maybe another one will be here, and then from 10 to 1000, and the difference right here will be 20 dB, because it's 20 dB per decade. Every 10 times of frequency you have 20 dB dropped. So what does this 10 means? That's dB. In other words, we get this 10 by taking 10 equal to 20 log of the magnitude of transfer. In other words, from here we can get Ti omega, which is then 10.5, which is equal to square root of 10. Let's see what we can get the number. It's about 3.16. In other words, when input frequency at 1, 10, 1 and 10, you also always have these amplifications. So my output signal steady state, again, is steady state after the transient part decay. I should have 3.16 times sine 1t, or let's just put t because 1 is unity. T plus small face here, and 3.16 times sine 10t plus another phase shift. You can plus now at 1000, meaning from this 100 or 10 or 1 radian, the drop is 20 dB. 20 dB in linear scale should be 1/10, so your drop become 0.316 sine 1000t plus phase 3. This is low pass filters.